I wanted to work problem 15 with you. 32% of customers who purchased products from an e-commerce site had orders exceeding $130. If 21% had orders exceeding $130 and also paid with the e-commerce site sponsored credit card, determine the probability that a customer whose order exceeds $130 will pay the sponsored credit card. So we want the probability that the customers, given that their order exceeds $130, the probability that they will pay with the sponsored credit card. So this is a situation where we would say we want the probability of B given A. And the probability of B in this situation is the probability that they will pay with their credit card. And then given A is the event that their order will exceed $130. So we're going to use this formula, the probability of A and B occurring. So the probability of A and B occurring would be this 21% divided by the probability of just A occurring, the probability that they had an order of 130 or more, and that would be 32%. So basically, the probability of both of them occurring is 0.21, and the probability of just the order being over $130 is 0.32. So if you divide 0.21 divided by 0.32 in your calculator, you get 0.656. And that is how we got that answer. Then on question number 16, these are using a deck of cards. So if you had a deck of cards, what is the probability that you would draw a 9, a 5, or a 6? Well, these are just or statements, and there's no way you could do an and here. You couldn't draw a 9 and a 5 at the same time. So basically, it's pretty straightforward. The chances of you drawing a 9 or a 6 or a 5, if you look at if you have your deck of cards, you know that there are 4 9s, 4 5s, and 4 6s in a deck of cards. So you would just do 4 out of 52, which is 1 out of 13, plus 1 out of 13, plus 1 out of 13, and you would get 0.231. Now, if you don't play cards, you can make you a cheat sheet if you need to kind of help you with your probabilities. Now, the probability of drawing a heart or a spade or a club, this is basically the same thing as this one as far as you can't draw a heart and a spade at the same time. It cannot be the same card. So there are, with hearts, spades, and diamonds, you have 13 of each. So 13 out of 52, that simplifies to 1/4. So 1/4 plus 1/4 plus 1/4 would be 3/4, which is 0.75. And then a probability of a 9, the probability of a 10, or a spade. So let's think about that. How many 9s do you have? You have 4. 4 out of 52. Okay? Or 113. And then how many 10s do you have? You have 4 out of 52, which is 1 over 13. So then you have to think about spades. Well, we have 13 out of 52 spades, but one of those spades is going to be a 9 of spades, and one of those spades is going to be a 10 of spades. So we've already counted those. So we only can get, we don't want a 9 and a spade at the same time. We want or. So the way I would do it is we're not going to say 13 out of 52 spades because we've already counted the 9 and we've already counted the 10. So that would be, if you wanted to put 13 out of 52, 1/4, you could, and then subtract out the 2, 9 of spades and 10 of spades. But I'll just say 13 out of 52. I'm going to subtract 2 of those because we've already counted those and say 11 out of 52. So 1/13 plus 1/13, and then you want to add the 11 out of 52. And you would get, it should be 0.365. Okay, and then the last one, you have a 6. Okay, there's 4 6s in a deck of cards out of 52 cards. 4 out of 52 simplifies to 1/13. And then there are 4 jacks. There are 4 jacks in a deck of cards, so 4 out of 52 would be 1 out of 13. So 1/13 plus 1/13. Now hearts. There are 13 hearts out of 52 cards. So 13 divided by 52 would simplify to 1/4. And then there are, same thing for spades, 1/4. So we have 1 out of 13 plus 1 out of 13 plus 1 out of 4 plus 1 out of 4. Now we can also have a 6 of hearts and a 6 of spades. So we don't want to have both at the same time. So we're going to subtract out the 1 out of 52 6 of hearts and the 1 out of 52 6 of spades because we want the ands out. And then we can also have, let's see what I'm missing one more thing. Okay, the jacks. Okay, we can have the jack and the heart. We'll subtract that one out, and the jack of spades, we'll subtract that one out. So you end up having 1 out of 13 plus 1 out of 13 plus 1/4 plus 1/4 minus the 1 out of 52 for the 6 of hearts and minus the 1 out of 52 for the 6 of spades, and then minus the 1 out of 52 jack of hearts and minus 1 out of 52 jack of spades, and that would give you 0.577. So it's really all about knowing your cards on that one. Okay, moving on to question number 17. Suppose that a poll finds that 37.3% of taxpayers who file their tax return electronically self-prepare their taxes. If 3 tax returns submitted electronically are randomly selected, what is the probability that all 3 were self-prepared? We know the probability of it happening one time is 0.373. So basically, you're going to do 0.373 times 0.373 times 0.373, and the probability of finding all 3 tax returns were self-prepared would be 0.052. That is a pretty straightforward problem. Okay, and then on problem number 18, you could set this up in Excel if you wanted to and work this. I'm not going to work all of it just because we'll run out of time, but I can show you how to work some of these quickly. Give it just a second to open up. So I would sum everything on this side. Just add it up. And then I would just add this up. And then I would sum it across, and that way everything will be easier to calculate if you've summed everything up automatically. This should add up to this, and these two should add up to this. So let's look really quickly. Determine the probability of selecting a female. So all you would do is do your total females divided by your total number of people, and you would get 0.600. And then determine the probability of selecting a student that is 22 to 24 years old. So here you would go to your total number of students that are 22 to 24 years old and divide that by your total number of people, and you would get 0.176. Let me find where I am. Alright, determine the probability of selecting a woman who is 35 years or older. So 35 years or older. So you would do the women divided by the total, and you would get 0.208. And then determine the probability of selecting a man given that the student is 22 to 24 years old. So we're only looking at 22 to 24 years old. So this is our total that we will be using. It's not total everybody. It's given that they're in this bracket. So the probability of it being a man would be 550 divided by your total. So 0.447. When it says given, you have to use that as your total number. So here on F, given that the student is a man, determine the probability of selecting a student that is 30 to 34 years old, given that the student is a man. So we only have to look at this total here. So here, 22 to 24 years old man, add a total men, and we get 0.197. Oh, I looked at the wrong one. 30 to 34 years old. So let me go back and fix that. 30 to 34 years old would not be B5. It would be this one, B7. So 0.153. 0.154. Did I not round right? 0.15. That would be 0.154. It should round up. I'm not sure what I did wrong there. Determine the probability of selecting a student that is 30 to 34 years old, given that the student is a man. So 428 divided by 27.9. I'm guessing my rounding is a little off there, and that is why I got 0.154. Let's make sure I sum this up right. Let's try it again. So 30 to 34 years old divided by 2791, 0.153. I will clear that up in the next video. I'm not sure why I got 0.154. I'm probably just overlooking it. But that should give you a good start on 4.2, those few problems. And I believe 19 is very similar to problem 18. You can open this in Excel and work it very similar to what we just did.